20 years ago, Bill Joy talked about the 8 fallacies of distributed computing. These are things such as the network is reliable, and latency is 0, and bandwidth is infinite. And these fallacies are even more relevant today. With the popularity of Docker containers and the networks of distributed systems that we deal with, things have become even more complex, and the fallacies keep coming up. They're still relevant, and with this growing complexity comes new problems and new fallacies. WeaveWorks is a company building simple, reliable ways to manage containers and microservices. The CEO of WeaveWorks, Alexis Richardson, joins the show today to discuss how Weave uses convergent replicated data types to manage distributed systems. The use of the CRDT data structure is in contrast to the use of algorithmically managed Paxos or Raft-based distributed systems strategies. Our conversation also touches on the Cloud Native Computing Foundation, which is similar to the Apache Foundation, but for cloud native application technologies. Software Engineering Daily is looking for sponsors for Q3. If you're interested in having your company sponsor Software Engineering Daily, please send me an email at softwareengineeringdaily@gmail.com. And if you enjoy the show, always, I appreciate it when you share it on Facebook or Twitter. The show grows by word of mouth. So you can also just send me an email to give me some feedback or say hi. I always love hearing from people who listen to the show. After a message from today's sponsor, we will get to this episode, WeaveWorks with Alexis Richardson. As an engineer, you want to minimize scalability issues. When there is high traffic to your application, you need your content delivered with 100% availability. CacheFly is the content delivery network with the fastest global throughput. Every application needs a CDN, whether you are in gaming or ad tech or social networking or e-commerce. If you're at scale, you need a CDN. Go to cachefly.com. That's CACHEFLY.com and use promo code SEDaily for a 14-day, 2 terabyte free trial. 65% of CacheFly customers use CacheFly for software distribution because CacheFly has the fastest throughput globally for large files. Try out CacheFly for free today. There's a 14-day free trial up to 2 terabytes of bandwidth. And if you use promo code SEDaily, you can help support Software Engineering Daily. If you want your app to be successful, you can't have delays and downtime. So check out CacheFly, CACHEFLY.com, and use promo code SEDaily for a discount. It would support the show. Now let's get on with the show. And thanks to CacheFly for being the newest sponsor of Software Engineering Daily. Alexis Richardson is the co-founder of WeaveWorks. Alexis, welcome to Software Engineering Daily.
Hi there, Jeff. Great to meet you.
Weave allows us to build a resilient network of containers, and we will get into that discussion. But I want to start by talking more generally, just about distributed systems in general. What are the characteristics of a reliable production distributed system?
I think there's lots of different definitions of reliable, but I think that the most important is that when a user wishes to execute an action, that action is always possible, and if it fails to complete, it should do so in a manner that makes sense to the user.
So 20 years ago, Bill Joy was talking about the 8 fallacies of distributed computing, and these are things like the network is reliable, latency is 0, bandwidth is infinite. There are another 5 or 6 fallacies, and these fallacies are still relevant today. Are there any new fallacies of distributed computing that have become widely believed in recent years?
So, Jeff, that's a really great question. Modern myths of distributed computing. I mean, I think the myths never really go away. They keep coming back in new forms. But my favorite today that I think is really crucial is this idea that a lot of applications can be built by selecting some kind of platform, whether it's a container platform or a cloud and container platform or a PaaS, and then everything will be taken care of for you by this platform. And you just have to write the application, and it will figure out how to deal with the hard problems of distributed computing for you. And that is kind of a 8 myths in a box level of wrongness. It's just not true. And that is why so many applications continue to be written using infrastructure and services rather than a aggregated set of platform components out of the box. And I think that will remain true for a while until at least until the point where people stop building different types of application and all build the same kind of application like a web app or something. Maybe then it'll be standardized. But today, I think it's true.
Yeah, okay, I think that's a great answer. So another, I totally agree with what you said. The 8 fallacies in a box platform answer. There's also this thing, I think, when we talk about tools that are useful for managing distributed state, we have these things like etcd and Console and Zookeeper, and all of these tools use a consensus algorithm like Paxos or Raft, and they have strong consistency guarantees. And I think we've, over time, we've kind of gotten used to these things as having a tight mapping to how we think about distributed systems. Are there some pros and cons of this model of distributed state management systems where we're using etcd and Console and Zookeeper and have these stronger guarantees about consistency?
Absolutely, there are pros and cons. And if you have been doing computing for a while, we are in the consensus algorithm era, very much recapitulating the fascination with distributed transactions that took place in the 1990s, which were introduced as a mechanism for delivering a certain kind of reliability for a large-scale system, in other words, a distributed system, and which got people into trouble because they didn't always understand when to use them and how to use them, and people would end up using them all the time or not at all, which is not a bad which is not a good thing. Using them all the time is a very bad thing because you have resources getting locked up and people walking away from the transaction, which then have to be dealt with. And not using them at all can be bad because sometimes you do need strong consistency. And the move to consensus-based algorithms has definitely improved things. And one thing I would say to people is, don't write your own consensus-based algorithm. The implementations of Paxos and Raft that are out there are good, and Zookeeper, etcd, Console, respectively, for Paxos, Raft, and there are other things out there too. Those are good solutions for doing consensus. It's not a good idea to implement your own or reinvent the algorithm. Having said that, there is a high performance penalty to getting consensus among a large number of, let's say 3 or more actors on a network, which is too high to pay inside every single transaction. And so what we find is that, it's not a good idea to use consensus all the time. And then you have to decide when not to use consensus. And there are other things that can go wrong when using consensus all the time. For example, in order to maintain consistency, if there is a network partition, then typically a state that is in core it or the subsystem that is in core it will deny reads or writes on the part of the user in order to maintain consistency when the two partitions reconnect. And another approach to this, which is the one that we favor and is used by things like global DNS, actually, and is used by Amazon for S3 and many other large-scale systems, is an eventually consistent model, and that's something that we use inside our network and our service discovery tool. And the advantage of this is, it's partition tolerant, it gives the user highly available access all the time, and it sorts out inconsistencies using a merge-based system based on CRDTs.
Right. And in contrast to Paxos and Raft, this solves the problem of consensus management by a data structure-centric approach. The Paxos and Raft is like this algorithmic approach to constantly getting a quorum around the state of your data. And with CRDTs, you're more, instead of involving everybody in the network and trying to get this quorum, you just have this data structure that you try to maintain and propagate throughout the network over time. And that data structure is the CRDT, this convergent replicated data type. Could you give a simple example for how a CRDT works?
I'm probably not the right person to answer this question. It works. I mean, if you'll accept a hand-waving, not quite right answer.
That's the only type of answer I accept, actually.
Okay, very good. In that case, we're good to go. It works like GitHub. I mean, everybody intuitively understands that the GitHub model is one which supports multiple version concurrency, and it enables merges if they take place on independent pieces of code. So it's quite difficult to get inconsistent merges in a large-scale system on GitHub if you have a small number of programmers, because they're working on different things. And CRDTs are based on the same idea that you can bring together two different sets of changes on a common set of data, provided they're on different things. And even if they're on the same thing, then there is a set of rules you can follow which will help you out.
So now that we have some background into the way that Weave looks at distributed systems, let's talk some about the Weave products. And I think one simple place to start is Weave DNS. Could you explain what a DNS service does and what Weave DNS does that's different?
Sure. So Weave DNS is based on Weave Mesh, which is our underlying system for handling these distributed systems in an eventually consistent way. And I should stress before I talk about DNS that we're not saying to people don't use consensus at all. We're saying to people, in the cases where you don't need consensus, here's a really good tool to use which will give you the level of consistency that you need in those cases, so that you don't have to use consensus all the time. You don't need to. A good developer should never have just one tool in their box, okay? And we actually use consensus and strong consistency ourselves in another case we'll come to in a minute. Now, Weave DNS is a service discovery tool. All it does is it maintains a very fast distributed set of service names using a DNS API to query them across the system, which means that everybody who is using Weavenet, once their app or their container has been granted IP addresses, can give them a service name in an intuitive way without having to learn any new technology. And that is more than enough for a lot of service discovery cases. The difference between this and regular DNS is something which updates very slowly. It's there to support the global internet. We've optimized our implementation so that it's suitable for service discovery cases. The one thing to bear in mind is that if you're using a DNS-based system for service discovery, you want to make sure that the IP addresses are persistent, by which I mean that they, if you get an IP address back from DNS as the service address, then you can keep on using that IP address. Otherwise, you have to make a lookup every time. So we solve that problem using other techniques. But at its root, Weave DNS is a fast, high-performance, optimized DNS system, which is highly resilient because it's based on Weave Mesh, which is an eventually consistent model.
Is there something about DNS and service discovery that has fundamentally changed since containers have started becoming popular and in wide use?
There's a lot of confusion about this stuff. I mean, number one, there's confusion about whether you need to have a strongly consistent model. Number two, there's a lot of people kind of overuse these tools for things. But I think that other than that, actually what we're seeing with containers, and it's been said before by others, is a move back to the computing models of the past in a good way. So, with a container, you're essentially dealing with a machine. It's just a kind of portable, kind of virtual machine. And, what you want to do is deal with setting up that machine in as simple a way as possible. And the simplest way possible is all of that amazing technology that was developed between the 70s and the 90s for managing machines like networks and storage and service discovery and all of those good things. And, that means that what you don't need to worry about is a whole load of other kind of stuff that was invented later in the era of Java that sort of sits on top of machines about, JVMs and APIs and transaction models, all of which is great, but you actually don't need it for a lot of applications. So, yeah.
So Weave DNS is just one component of what WeaveWorks, the company that you co-founded, is working on. So now that listeners kind of are getting an idea for the kinds of problems that you're working on, explain what Weave is. Like, what is your company WeaveWorks doing?
So WeaveWorks is essentially delivering a complete stack for people who want to build microservices applications, focusing on solving problems independent of the choice of container and the choice of orchestration tool.
What are the main products that WeaveWorks is building to achieve this goal of allowing basically anybody to build microservices?
So Weave is building a complete tool chain for microservices designed for developers and DevOps teams who want to build microservices very quickly, want to understand the new patterns, and have help from the tooling to enable them to do that. Patterns like, blue, green, canary, tracing, flow management, segmentation, and so on. And in our tooling, the key idea is that we're not telling you which container to use, and we're not telling you which orchestrator to use. So we are focusing on working with the grain of Docker, Kubernetes, DCOS from Mesosphere, and other tools like Amazon ECS, for example. And in our approach, it's very much due to the way the technology is designed that we can do this. You choose your platform, and in many cases, you're going to have multiple platforms. One might be a Mesosphere, one might be a Kubernetes, one might be a Docker. And you can build applications in a faster, simpler, and more consistent manner and still run them on these platforms, which is, I think, very beneficial to end users who want help building these types of applications. And that breaks down into key areas of functionality, and you see those in our open source products like WeaveScope, for example, which is a monitoring and visualization tool, or Weavenet, which gives you networking and service discovery, and so on.
So let's talk about Weavenet in more detail. And Weavenet creates a virtual network that connects Docker containers together. So why do I need this? Like, I thought this is something that is covered by Kubernetes or Mesosphere, Mesos or ECS. I thought that these container orchestration systems took care of this thing. Why do I need Weavenet to create a virtual network between my Docker containers?
Yeah, absolutely. I mean, this is a great question. Weavenet should be used with other platforms because it delivers better networking in key use cases. Sometimes, for example, you need a feature that Weavenet provides that isn't provided by many platforms and networks. And one of the ones that we keep running into today is, for example, multicast. Multicast does not work easily in cloud environments. You usually have to synthesize it yourself. And we've been able to do that and embed that into Weavenet so that if you have a multicast-based application, e.g. for discovery or instrumentation or market data if you're in finance, then Weavenet will take care of it. One of our largest customers, the International Securities Exchange, a big options trading exchange out in New York, now part of the NASDAQ actually, uses it to distribute their market data onto Amazon Cloud and into a big financial data center that they run because Weavenet enabled multicast out of the box, and they could run their existing technology over Weavenet in a way that was just easier and still high performance than everything else they tried. So the one answer to your question is there are some things that we do that other people just don't do. And another one is there's more general cases where having control over the network yourself is advantageous, and that's when you want to use it instead of whatever the platform is providing.
And so you're talking about these things that are different in Weavenet or in Weave that are they're different in the platforms themselves. One way I think maybe connects back to the previous conversation we had about CRDTs is that all the other Docker networking plugins require setting up this central database like Console or Zookeeper. How does Weavenet contrast with this? So
with Weavenet, because the consistency model is baked into the product itself through an eventually consistent, highly resilient mesh, you don't need to set up an external store to look after all your metadata in the network. Whereas with some other networks and platform network implementations, they do things like putting all of the network metadata into etcd, which means that, for example, if there's a network partition, in the case of Docker, there are no reads and writes on the minority side, which means in turn that that network will completely freeze up and no one will know what's going on, which is essentially an unreliable solution. Now, in fairness to the implementers, no doubt they'll think of ways to solve this problem later. They're focusing on a more tightly coupled scenario at the beginning where partitions will be very rare. Fair enough. I do not object to that. But I do think that it's worth bearing in mind that it's much better to have a single thing that could go wrong than to have two or more things that could go wrong. And I think that's a fundamental difference between Weavenet and many other networking implementations that you'll see out there. And if you're a buyer or if you're a technology decision maker, one of the top questions you should ask the vendor is, how do you deal with this? You know, what happens if things go wrong? And can I get caught out in this way?
I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month. So my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. One conversation that I see around the Weavenet product is that, like, today, most of, if I've got some container stack, probably all of my containers are in Kubernetes running on Google Compute Cloud, or all of them are in Mesos running on Amazon, or they're on ECS running on Amazon, and they're all in this box. But tomorrow, I may want to have some of my containers in Kubernetes, some of them on ECS, some of them in Mesos. And my sense is that Weavenet is going to be this communication layer that is reliable, that is the best choice to use to communicate between containers on these different platforms. Is that accurate? Is that positioning accurate?
Yes. I mean, I think that's when I said earlier that we're offering a complete tool chain for microservices independent of the choice of orchestrator. What we have in mind is customers who might, for example, be using Amazon ECS for their Amazon-based apps, Kubernetes on EC2 or somewhere else for other reasons, and Docker Swarm in many, many, many cases, because Docker Swarm is a good tool as well. So what happens if you want these applications to communicate? Wouldn't it be great if you had either one consistent approach to networking, or if they were even on one network, which could stretch across, for example, multiple data centers securely? And Weavenet does that, which makes it basically an awesome tool for those cases. And so that was the other reason I was going to earlier with the why is Weavenet better. One is it has specific functionality it supports, and the other is it's just really amazing and flexible and simple in these kind of cases that you might care about down the road.
So I do want to talk some about this macro picture. We have Kubernetes and Mesos and Amazon ECS, Docker Swarm. The list goes on for these platforms that are trying to be the thing that you build all of your infrastructure on. And I love to ask guests what their perspective is, how these services actually differ from one another, and what does the future look like? So give me your perspective. Like, Why are there all these platforms that it seems like there's like significantly overlapping functionality?
Right. I mean, this is a really interesting question. I think this kind of gets to the heart of questions people should be asking about the industry as a whole. It's all very well differentiating on features, but candidly and frankly, the typical user is not going to care about that. They're going to care about the core 80% of features being implemented well, and those features will be the same on each of the main platforms. Now, they might be implemented in different ways, and there might be advantages to doing them one way or another way across the development and operations spectrum. No question about that. But when it comes down to it, the core features will be, starting and stopping multiple containers, maintaining N replicas, that kind of thing. And, that means there's going to be essentially an implied common model across these platforms, and that will be the model that most applications use. So actually, you would then ask, well, shouldn't we be thinking this as part of the furniture and a commodity layer? And I think that's what's ultimately going to happen, is that that core 80% of functionality will commoditize. And therefore, ultimately, the people who will make the most money out of it will be people who can build a cloud-type revenue stream out of it, which will be, number one, the public cloud providers, and number two, and I wish them luck with this, companies like Docker, Mesosphere, and some of the Kubernetes players may be able to do this.
Well, so when we talk about commodities, like when I think about commodities markets, like I think about the oil market. And one interesting thing about the oil market is that it is this commodity, but actually it's a commodity market where there are all these different players that have slightly differentiated offerings because the market is so gigantic and it does have specific needs. Like different users have different specific needs of the types of oil that they want, like at what level of refinement they want. Is this going to really be a winner-take-all market where there's one commodity provider that it just wins everything, or is it going to be where like some people want Kubernetes, some people want Mesos, some people want ECS, some people want Docker Swarm because of very real and tangible reasons that may or may not be visible right now?
Right. So I'm not sure if saying that DCOS or Mesosphere or Mesos are the same as Kubernetes and Swarm is quite the right way to look at it.
Okay. I
think, and that's partly my fault. I mean, I was doing that too earlier on. I think there are things like Marathon, which sit on top of DCOS or Mesos, which are more like perhaps Kubernetes in their aspiration. And I think Mesos's fundamental design center is a little bit lower down the stack than Kubernetes. Nonetheless, in the large, these are trying to do similar things. I think the market is going to sustain at least 2, possibly 3 different technologies here, just in commodity open source infrastructure, just because there are different scaling issues that you run into that you want to optimize for in different ways. And if you talk to the Mesos teams, they will very much talk about sorting, they're kind of, the thing that drives them is very large scale data driven applications. Whereas I think, what drives Docker came out of the PaaS world, and it started off with applications that are PaaS type applications, and it's generalized since then. And, Kubernetes is a mixture of the two, because that's what you have in Google's data centers, and that's where Kubernetes' original design came from as well. So they're starting from 3 very, very different places, and I think they could all end up doing the same thing, or they could specialize. And I honestly wouldn't want to predict what will happen there. And I certainly think there's room for multiple implementations based on different special cases and strengths and weaknesses, no question.
Absolutely. Okay. So, but there is one prognostication that you were willing to make that I heard in a podcast interview. And this is a really interesting point. And the podcast is the Cloudcast for people who are curious. It's a great podcast. And on this podcast, you drew an analogy between Docker, the company Docker, their business strategy, and how VMware's business has evolved. And I thought this was really interesting because I hadn't heard anybody else draw this parallel before. Could you explain the parallel between how you see Docker, the company, evolving, and how VMware currently looks today, how their business model has evolved?
Well, one of the great things about making predictions about the future is that you can make different ones every time people ask you these questions. And I think, it's worth bearing in mind that the market allowed VMware to create a monopoly in the virtual data center, which was unexpected because when virtualization was first created in the 90s it was the rebirth of virtualization. Obviously, it was originally a mainframe technology. Many people thought it wouldn't be possible, wouldn't be useful at the level of commodity computing, mom and pop's desktop or the small business data center. And VMware proved everybody totally wrong. And it took the rest of the world quite a long time to realize what was going on. Consequently, VMware ended up with sort of 70 or 80% of the mainstream enterprise workloads in the data center, and that is what's called a stranglehold. It became very frustrating for everybody else who wanted to innovate on that layer, because they would have to use VMware's APIs and technology, and so people tried to do things like using KVM or Xen, and ultimately Amazon, for example, used an open source virtual machine and forked it. Microsoft took a long time getting Hyper-V to market and then built Azure on top of that, I believe, although that may be not quite right. So nobody wants that to happen again. And what you could argue that the attempt to remove the VMware monopoly through open source virtualization failed, but the attempt to remove the VMware monopoly through a different approach to componentization and automation, a more general problem, through containers, will succeed, because there are enough benefits to switching technologies. That was always the problem, is if I get rid of VMware VMs and switch to an open source VM, what are the reasons I should do that? And there was never enough reason to change. Even if the open source technology achieved parity, many customers wouldn't be ready to change. It would require effort, it would require risk. But moving to containerization has material benefits in terms of portability across different implementations of clouds and VMs, and capacity management. So you can actually build applications out of containers, which, believe me, you could never really do with VMs properly. And so there is enough reason to change. And so they've got this incredible line of attack on the whole virtualization market. And the thing that's driving a lot of what Docker is doing is to create tools that application developers can use, which are going to accelerate that change. But ultimately, what is being sold and being bought by companies and customers of Docker is, an operation-centric solution for the data center, which is something that can replace or sit on top of or complement or gradually disrupt, take your pick, VMware vCenter.
And so what is I see this tension here, because you've got Docker, this company, and then Docker, this open source tool that everybody is using and building their own platforms on. And I don't know, it's interesting because it's how does this shape up? And we haven't even talked about the CNCF, which you are a part of, the Cloud Native Computing Foundation, which is this organization that is kind of trying to create harmony in this space. But as a member of the CNCF, how do you look at this tension between the fact that Docker is this technology that everybody is building on top of, and yet simultaneously Docker is a business that probably has aspirations to own as much of this space as possible?
Well, going back to your previous point about commodities and oil, I think it's worth noting that the word commodity is used to describe many different things. In the oil markets, oil is a commodity based on price. The price is an international oil price set according to a number of benchmarks. And then all the different kinds of oil are different ways of delivering against that common price. So, you might pay more if, for example, you had to ship the oil a long way to actually get to it. Whereas in other markets, notably food, the commodities are not fungible. So you have things like completely different types of wheat, and the wheat markets are not coupled to, say, the orange juice markets. And so, we talk about food being a commodity or wheat being a commodity, but actually it's not a commodity in the same sense that oil is based on price. So what does that mean for us in terms of computers and containers and virtual machines? I think when people talk about CPU, that can be a commodity similar to oil or electricity. In other words, it's a commodity based on price, and the question is only about what's the cost of delivery against that price of the physical goods. In the case of containers and applications, I think you're going to see differentiation. So Docker may be incredibly successful with solving a certain class of problems that look like the ones that they started out doing because that's their core strength, whereas other players may be successful in other areas. And I think what everyone will do is actually include these technologies in larger solutions, which ultimately may play more into the hands of people who are capital rich, like Amazon, Google, Microsoft, and others like IBM and so on, the cloud providers. So therefore, I think although Docker may look like they wish to own everything, I think realistically, if you got the leadership of Docker around the table for a beer, they would admit that, like a peacock, they've got to look a lot bigger and more handsome than they really are. But actually, even if they got a significant share of this market, it would just be an amazing win for them.
So as a member of the CNCF, and you have all these different big players that are involved in these technologies that CNCF is kind of stewarding over, what is the role of the CNCF? What are you trying to do, and how do you mediate the conversations between these different companies, like a conversation between Google and Docker, for example? Like, how do you prevent acrimony and I don't know, stalling in these communities, or what is the role of the CNCF as an arbitrator there?
So the CNCF could try to be an arbitrator between these different competing interests, but actually isn't necessarily seeking to do that. It's not trying to find areas where we disagree and focusing on those in order to see if we can actually agree. I think that is what a standards body does, and I think that characterizes the OCI, the Open Container Initiative, which is a genuine attempt to standardize certain definitions around container implementations and specs, such that people can talk about a standard container. And the way that works is you go, okay, do we all agree on the standard container definition? And then the answer is no, we do not agree. And then you say, okay, what are the areas we don't agree? Let's fix those. And that's where you encourage disagreement and then try to resolve it. With the CNCF, we're not taking that approach. We're not trying to be a standards body or a kingmaker. What instead we're trying to do is find areas where we all agree there are good technologies that people should be using in this new cloud-native environment that we all are trying to engender. So WeaveWorks, Khoros, Google, Mesosphere, Docker, Cisco, and the other, and Joint now, of course, Samsung, the others who are involved, we agree on lots of things. And a good example is the introduction of Prometheus into the CNCF. Prometheus is a monitoring tool which also embeds a time series database, which is queryable for analytics. What a great tool. It's designed for a dynamic cloud-native type environment. It's designed originally within companies that SoundCloud that represent the type of architectures that cloud-native is all about. Running some stuff on Amazon, some stuff in-house, moving things around, and so on. And so this is a tool which everybody in the TOC could very quickly agree would be useful to all customers, no matter whether they're using Docker, Kubernetes, Mesos, Weave, Khoros, Tectonic, what have you, or some combination thereof. And so it's actually really good to be able to send a strong signal to the market. This is a technology that's going places that you can trust. And you shouldn't be so confused, because here are some things that we believe actually will work well for you.
Okay, well, Alexis, I know we're up against time, and I want to respect that time. You have touched on a lot of different interesting things. And for listeners who are more curious about Alexis's positions on certain things, there's a really good post on the new stack called the Post-Amazon Challenge that you wrote, which kind of touches on some of the things about where we are, where we're going, and what Weave's position is in that space. So, Alexis, thanks for coming on the show. I'll put that in the show notes. And I hope to have you back on Software Engineering Daily sometime in the future.
Thank you very, very much, Jeff. I really appreciate it.